Physics 2212, Lab 1, Charge Tapes. In this lab, I created two pieces of charge tape by placing a piece of tape on a base tape and ripping it off quickly. I then observed the tape's interaction with other charged and neutral objects to determine the sign of the charge. I then determined the excess charge on the tape by recording the distance at which two tapes will begin to repel each other. The purpose of this experiment is to calculate the amount of excess charge on each piece of charged tape and to determine the number of extra or deficient electrons on one piece of tape. The system in this experiment is the two charge tapes, and the surroundings are everything else. Some key concepts and models of this experiment are electric fields and forces, which are created by any charged particles. There's the point charge model and the line charge model. There's also Newton's second law, net force is equal to mass times acceleration, which can be used in the point charge model, and Coulomb's law, which is seen below. In this experiment, we have a few assumptions, the first being that there's no air resistance. The point charge model assumes that all the charge on one piece of charge tape is located at one point in the center of the tape, and a line charge model assumes that all the charge on one piece of tape is distributed across the surface of the tape. Each charge tape is assumed to have the same net charge. The final results of the experiment were that the charged pieces of tapes were repulsed by each other, implying that each tape acquired the same charge. These charged tapes were found to be positively charged by observing their interactions with negatively charged objects. The charge of each tape was calculated as 1.14 times 10 to the negative 8 coulombs using the point charge model, and each tape was deficient of 7.125 times 10 to the 10th electrons. Some initial observations were that tape B was attracted to my hand, a neutral piece of wood, and a negatively charged pen. Tape B was repelled by tape A, and tape B began to float when it was 0.023 meters from tape A. The conclusions from these observations are that tape B was positively charged and therefore had lost electrons during the charging process. This slide shows the calculations to calculate the charge of the tapes using the point charge model, where I found the magnitude of gravitational force on tape B, set that equal to the electric force, because Newton's second law tells us that if the acceleration of the top tape is 0, which it is, the electric force will equal the gravitational force, and then I used Coulomb's law to find the charge of each tape. The number of electrons lost by each tape was then calculated by dividing the charge of each tape by the charge of one electron to find that each tape is deficient of about 7.125 times 10 to the 10th electrons. Then I found a ratio for electrons lost to number of atoms on the tape by determining the number of atoms on the tape by dividing the area of the tape by the area of an atom, which we know, to find that the atoms on the tape are 4.305 times 10 to the 17th atom. So for each tape, 1 electron is lost per 6.04 times 10 to the 6th atoms. Some possible errors in this experiment include measuring the dimensions of the tape incorrectly, which would impact the mass that I found, which would in turn impact the gravitational force, electric force, and charge that was calculated. Another error could be reading the distance between the tapes incorrectly, which would impact the charge that was calculated. The first Glowscript model is the point charge model. As seen on the left, it shows tape B, the top tape. It also represents the electric force on tape B by tape A as the weight arrow pointing up, and the gravitational force on tape B as the yellow arrow. These arrows are equal to each other as this model calculates the charge of the tape using Newton's second law. Next is the line charge model. In this code, the electric field was calculated as well as the electric force vector. The electric field vector is green. It is produced by the bottom tape on the top tape. This is similar to the electric force vector, which is the white arrow, which is produced by the bottom tape on the top tape. Additionally, the gravitational force is seen here, pointing down from the top tape. If the signs of protons and electrons were reversed, the tapes would become negatively charged. This would mean the tapes would repel negatively charged objects, like the plastic pen, though the tapes would interact with each other in the same way because like charges will always repel and opposite charges will always attract. The estimated value of the charge using a point charge model is 1.14 times 10 to the negative 8th coulombs, while the value using a line charge model is 1.04 times 10 to the negative 9th coulombs. The line charge model is most likely to be closer to the real value because realistically the charge of the tapes would be distributed throughout the surface of the tapes rather than just at one central point.